Now, from what I explained earlier about the basic trigonometric functions that we have, that is the sine, cosine, and tangent. Now we are going to application of those things that we have acquired. Now there is an example A which says if cos theta is equal to 5/13, calculate the values of A sin theta, B tan theta, then C sin square theta plus cos square theta. If you look at this last one, I was able to derive something the other time that sin square theta plus cos square theta is equal to 1. I derived that one using alphabet. Now we've come to a place where we need to use numbers to show if sin square theta plus cos square theta is actually 1. Now, the first thing that is very important here is to be able to interpret what we have here. When we just see cos, we have the solution. When we see cos theta, and we have cos theta to be 5/13, the first question we need to ask ourselves is this: cos theta is 5/13. What is 5 representing? What is 13 representing? Now, if cos theta should be 5/13, then we should have a corresponding value for sin theta. We should also have a corresponding value for tan theta. The first thing we do here is, from what we learned, we have K. C, I said, is representing cos. A is representing adjacent. And I said K is cosine is equal to adjacent over hypotenuse. So which means 5 here is the adjacent side of a right angle triangle. 30 here is the hypotenuse side. Then after that, we draw a right angle triangle. Now I will label this place theta, while I label this one as the symbol for the right angle that we have there. It's not in all cases that we must label this one as theta. We can as well label this one theta as well. So, but the side that is facing that theta is what we refer to as the opposite side. So this is our opposite side. And from what I have here, this one is hypotenuse and this one is adjacent. The adjacent side from here, this side will be 5. The hypotenuse side is 13. Now after this, we now need to go back to what Pythagoras Theorem says. And let me quickly recap that. Pythagoras Theorem says the square of the longest side of a right angle triangle, or the square of the hypotenuse side of a right angle triangle, is equal to the sum of the squares of the other two sides. Now if you take that to this, the hypotenuse side is 13, and I will represent this other side with an alphabet, maybe y, for instance. So I have 13 square is equal to y square plus 5 square. 13 raised to power 2 is simply 13 multiplied by 13. Then we leave y square as y square, or we can break it down as y multiplied by y. So this 5 square is also 5 multiplied by 5. I try to expand this because over the years I noticed that some students, while trying to find 13 square, they will just do 13 plus 13. But 13 square is simply 13 multiplied by 13. So we have 13 multiplied by 13, that is 169. Then our y square still remains y square. And the same thing with this. Some students, in the course of writing exam or trying to quickly finish a particular calculation, they write this one as 10 instead of the normal 5 multiplied by 5, which is 25. Now at this stage, the next thing to do from here is to collect like terms. We call it collection of like terms. We know that a boy is different from a girl. So we have a 169 and 25. They are the same. So we need to take this 25 to where this 169 is. And the sign in front of 25 is addition. So whenever addition sign crosses the equality sign, it will change to subtraction. The same thing also, assuming this one is subtraction sign, when we take it to the other side, it will become subtraction. So from there we have y squared is equal to 169 minus 25. Now removing 25 from 169, we have y squared is equal to 144. Now this is y squared and this one is 144. The next thing we need to do from here is to take the square root of both sides. And what do we mean by taking square root of both sides? Y squared is equal to 144. We need to look at two numbers that if you multiply to give us 144. So if you look at our multiplication table, we have all those perfect squares. 1 multiplied by 1 is 1. 2 multiplied by 2 is 4. 3 multiplied by 3 is 9. If you continue like that, we get to a point where we have 12 multiplied by 12, which will give us 144. So we take square root of both sides. So when we do that, we have square root of y squared is equal to the square root of 144. So this square here, we cancel this square root and our y will be 12. So we replace this y here with 12. So with the 12 that we've been able to calculate now, we now know the sides of this triangle. So that will now help us to get sine, to get tan, and even to simplify this last one too. So we go to the first one, we have to find sine theta. And I was able to explain the other time that sine theta is equal to opposite over hypotenuse. That is from so. Sine is equal to opposite over hypotenuse. Now we go back to our triangle. Which side is representing the opposite side? The opposite side from A is what? 12. That is 12. Then the hypotenuse side from A is 13. So the meaning of that is sine theta is equal to 12 over 13 if cos theta is equal to 5 over 13. Now the second one, we are also to get tan theta. Tan theta, from what I explained, I said tan is what? Toa. And toa is simply opposite over adjacent. So after that, we now go back to our triangle. Which side is representing opposite? That is 12. And which side is representing adjacent? That is 5. We can leave this one in this form. This is an improper fraction because the numerator is more than the denominator. So we can express it as a mixed fraction by saying 5 in 10 in 12 we have 2. 5 multiplied by 2 is 10, and if you remove 10 from 12 we'll be left with 2. Then this 5 will come in. So you can leave an answer like this or like this. So that's all the second one. Now the last part is asking us for sine squared theta plus cos squared theta. And we derive sine theta as 12 over 13. So this is 12 over 13 raised to power 2 plus cos theta is 5 over 13 raised to power 2. 12 raised to power 2, that is 12 multiplied by 12, which is 144. Divided by 13 raised to power 2 is 13 multiplied by 13, and that is 169. Plus 5 raised to power 2 is 5 multiplied by 5, which is giving us 25. And 13 raised to power 2 is 13 multiplied by 13, which is also giving us 169. And if you look at the two fractions that we have here, we observe that they are having the same denominator. Denominator is the one at the bottom. So this is 169, this is 169. And what we need to do here is to take what we call LCM. That is lowest common multiple. And the LCM of 169 and 169 is 169. So if you take that, we have this as 169. 169 in 169 will give us 1. 1 multiplied by the numerator, which is 144, will give us 144. 169 in 169 will also give us 1. 1 multiplied by 25 will give us 25. Now I got a question now that how can we get the square root of 144 without using calculator? Now without using our calculator, there's another way of getting the square root of 144 from there. And what we do is, this is y square. We write it as y multiplied by y. Now since y and y, they are the same thing, the next thing we need to do here is to get two numbers that will also be the same thing from here. Now if you use 3 multiplied by 3, that is 9, which is not up to this. 4 multiplied by 4 is 16. If you continue like that, the common one that we know, 10 multiplied by 10, we all know that one is 100. If you go 100 is still not up to this one, this is something we can quickly do if you are in an exam or if you are trying to solve a question that requires taking square roots. Now from here, if you try 11 multiplied by 11, the answer this will give us will not be up to this. Now we advance. If you go to 12 multiplied by 12 now, 2 multiplied by 2 will give us 4. 1 multiplied by 2 will give us 2. Then 2, we use this one, 2 multiplied by 1 will give us 2. And 1 multiplied by 1 will give us 1. So that is 4, 4, 1. So which means 12 multiplied by itself twice is giving us 144. Y is equal to 12. Y is equal to 12. So therefore from there, y is equal to 12. There is another method of getting the square root of a number. And that is what we call the factor method. We have this 144. We start dividing with prime numbers. And if you divide this one by 1, it will still give us 144. The lowest prime number we have is 2. 2 in 14 will give us 7. Then 2 in 4 will give us 2. Now we use 2 again, which is the lowest prime number. Now, if you continue dividing by 2, if you get to a point where 2 will not be able to divide what we have, then we'll try 3, because 3 is another prime number. A prime number is simply a number that can be divisible by 1 and itself. So from here, 2 in 7 will give us 3. As 2 multiplied by 3 is 6, so we'll be left with a remainder of 1. 2 in 12 will give us 6. Now, if you look at what we have again, we ask ourselves, can 2 divide this? 2 can divide it again. 2 can divide a number if the last digit of the number is an even number. So 6 is an even number. Even numbers are simply numbers that can be divided by 2. So 2 in 36, 2 in 3 will give us 1. Remainder 1. 2 in 16 will give us 8. Now this one again, the last number is an even number. So 2 will divide this. So 2 will give us 9. Now what we have now, this is 9, but is an odd number. An odd number is any number that 2 cannot divide. Now since 2 cannot divide this, now we try 3. Can 3 divide 9? 3 in 9 will give us 3. And we are left with 3. 3 can divide itself. So 3a is 1. Now we have 6 numbers here. But since we are taking square roots, we take them in 2s. Like this one, we have 2 and 2. So that is 1, 2. We have another 2 and 2. That is another 2. We have 3 and 3. That is 3. So if you multiply all, we have 2 multiplied by 2 multiplied by 3, which will give us 12 that we obtained earlier. So from here, the addition of 144 and 25 will give us 169, and our denominator still remains 169. So 169a1, 169a1. Since they are the same thing, that's why I just divided through by 169. From here, 13 can also divide this, and 13, let me even use 13. 13a will give us 13. 13a will give us 13. Now, there's nothing else to use to divide than 13. So this is 13 in 13, 1. Then 13 in 13, 1. So this one is giving us 1. So therefore from there, sine squared theta plus cos squared theta is equal to 1. Now, the last example I solved, I was able to justify that sine squared theta plus cos squared theta is equal to 1. It's something we can know, and it's not something we need to cram. We can derive that showing our steps. Since WAEC, at times final answer only carry a mark in WAEC. If you have a question that is carrying 8 marks, the final answer alone may be a mark. The other steps will be 7 marks. So that will lead us to this second example. We are given that cos x. Now we are not using theta again. This example is using x. I said something the other time that we can label our angle with anything. We can label it as capital A. We can label it as theta. We can decide to label it as alpha. But this time around, we are labeling our angle with x. Now, we will have something here. 0 degree is less than. The left arm is representing less than. You fold your arm like this. So, this is 0 degree is less than x, and x is at the same time less than 90. And the meaning of this is x is not 0 and x is not up to 90, but x can be very close to 90. That would be different from this. If you have 0 degree less than or equal to x less than or equal to 90, this is different from this. The interpretation of this is x can be 0 since we have equality sign, and x can be 90. That's the interpretation of this. So, and this one we can also say that x is an acute angle. And what do we mean by acute angle? An angle that is less than 90 degree. Or we can also say x is from first quadrant. So we are still going to that later. So if you now go to what the question is asking us, the first thing we have there is that cos x is equal to 3/5. Now we interpret this again. What is cosine? From car. So car is adjacent, which means 3 is adjacent and 5 is hypotenuse. Now after getting that, the next thing we do is to draw our right angle triangle. But this time around, I will draw the right angle triangle in an unfamiliar way. I will draw it in the slant form. Now I have this. If you have the triangle in the normal way or in the slant form, it is still the same thing. Once you know our right angle, the side that is facing the right angle will not change. It will still remain our hypotenuse. Once we label, you can label our x A, or we can label it A. If you have our x A, the side that is facing the angle that we are making reference to is what we call the opposite side. And the last side is what we call the adjacent side. Now the next thing to do from there is to slot in the values that we are given for cosine A. Adjacent is 3. Then we have hypotenuse to be 5. So the third side that we don't know, we can represent that one with any alphabet. Let's say K. You can make use of A, but don't use X, because we have used x to represent angle. So use another alphabet apart from x. So from here, since we have two sides and we don't know the third side, then we also go back to our Pythagoras theorem. So by going back to our Pythagoras theorem, it says the square of the hypotenuse. Our hypotenuse is 5. We have 5 square is equal to the square of this side, k, plus the square of this one, the last side, 3. So 5 square is still 5 multiplied by 5. Then k square still remains k square. Then plus 3 square is 3 multiplied by 3. 5 multiplied by 5 is giving us 25. Then we have k square, and 3 multiplied by 3 is giving us 9. So after this stage, the next thing we do is to collect like terms. So after collecting like terms, what we have k square to be 25 minus 9. This is turning to minus 9 because this plus 9 is crossing the equality sign. So that's why we have it as minus 9 instead of the plus 9 that we have here. So from here, k square is equal to 16. Now we've come to the point where we need to find the square root. Now, we can use the method I explained earlier. We have 16. 2 can divide 16 without giving us any remainder, because the last digit here is an even number. 2 in 16 will give us 8. Then 8 is also an even number. 2 can divide it. 2 in 8 will give us 4. 4 is also an even number. 2 in 4 will give us 2. And we can use 2 also. 2 in 2 will give us 1. So we take them in 2s. So this will be taken as 2. And this 2 will also be taken as a single 2. So which means that is 2 multiplied by 2, which is 4. So therefore from here, if you take square root of both sides, we have k square root of k square is equal to square root of 16. So from there, k is simply 4. So this is 4. Instead of k, I'll replace that one with 4. Now, after knowing the sides, the next thing is to get the value of sine x and to get the value of tan x too. Then we now substitute everything together with the value of cos x that we are given in the question. We now substitute them back into this expression that we have here. So from there, sine x is from our sine x is equal to opposite over hypotenuse. So from this triangle now, what is our opposite? Our opposite is 4. What is our hypotenuse? That is 5. We already know cos x to be 3 over 5. Now, the next thing to do is to generate tan x, which is opposite over adjacent. And what is our opposite side? That is 4. And what's our adjacent side? That is 3. Now, the next thing we do now is to slot in these values. The value of cos, value of sine, and value of tan. We slot them into what we have here, into this expression. So that will be 3 multiplied by, since sine is 4 over 5, we put that in the bracket to differentiate the 2. So minus 2 into cos, that is 3 over 5. Then everything divided by 5 times x. So this is 5 multiplied by tan is 4 over 3. So when we are multiplying a fraction with an whole number, the numerator of the fraction will be the only one to multiply the whole number. We cannot say this is 12 over 15. It's not possible. We only use this 3 to multiply 4. From here, we use this 2 here to multiply 3. We use 2 to multiply 3, and from here we use 5 to multiply 4. So this one will give us 3 multiplied by 4, that is 12 over 5, minus 2 multiplied by 3, that is 6 over 5. So since this line is representing division, so instead of writing this, we can replace that one with division sign, and this one will be 20 over 3. Now from there, the next thing we do is to find the LCM of these two. This is 5 and this is 5, and the LCM from there will give us 5. 5 and 5 will give us 1, and if we multiply that one with this numerator, we have 12 minus 5 and 5 will still give us 1, multiplied by this numerator we still have 6. Now then, this division sign, we need to change it to multiplication sign, and to change the division sign to multiplication sign, the numerator of the next fraction will become the denominator, while the denominator will become the numerator. So this is multiplied by 3 over 20. Now 12 minus 6 is giving us 6 over 5, then 3 over 20. Now if you look at what we have, what can we use to divide from A? 3 cannot divide 5 without giving us a remainder, but there's something that can divide 6 and at the same time divide 20 without giving us any remainder. So that is 2. 2 from where will give us 3, and 2 from where will give us 10. So 3 multiplied by 3 is giving us 9, and 5 multiplied by 10 is giving us 50. So the result to this expression is 9 over 50. Now I got some questions, and the first question I got was, how do we know which one will be where our right angle will be produced? Our right angle is produced where the two lines, the two short lines apart from the hypotenuse, since I said it earlier that the longest side of a right angle triangle is the hypotenuse, where the two other lines, where they meet, that is where the right angle will be produced. Or where your horizontal line and your vertical line, where they meet, at that point the right angle will be produced. Then another question, when I was explaining the other time, I said this 3 here, which is a whole number, will only multiply the numerator a, and the reason for that is because for this 3, for any whole number, there is always an invisible one, which you can, that means you are expressing this one as a ratio or as a fraction. So 3 over 1 will also give us 3. So by dividing any number by 1, it will not change the number. This one 2 divided by 1, and this one 2, you can put this one as 5 divided by 1. So 3 multiplied by 4 is giving us 12, and 1 multiplied by 5 is giving us 5. 2 multiplied by 3 here is giving us 6, and 1 multiplied by 5 is giving us 5. The same thing with this one, 5 multiplied by 4 is giving us 20, while 1 multiplied by 3 is giving us 3. And that is the answer to those questions.